Hello and welcome to the Math Jedi. Today we are going to use the Force, young Padawans, and learn how to solve multi-step equations. That's right, get out your lightsabers, your blasters, and away we go. Today we are talking about solving. And this is solving using all the different skills that we have already learned. And if you're like, wait, I haven't learned anything, then you want to go back and watch my other videos. And we just call this solving multi-step equations. So we're going to kind of take the idea of adding, subtracting, multiplying, dividing, and we're going to go and figure out what is the best practice. So there's a few things. There's a few conceptual things I want you to know about. One of the things is like kind of things to keep in mind is number one is the golden rule. We know the golden rule in life is do unto others as you would want them to do unto you. Right? That makes sense. If we could all do that, that'd be great. But for math, it's what you do to one side, you must do to the other side. One side, both sides. Okay? So it keeps balance. So if I put it into a Jedi formula, it's obviously keeping balance in the Force. So that's one thing to keep in mind. The second thing that I would like you to keep in mind, and these are just some general rules, is you typically want to get rid of fractions. So these are kinds of things to kind of keep in mind. You want to get rid of fractions because typically fractions cause issues, and that's just a good way. And how do you do that? You just multiply things by LCMs, and they magically disappear. It's not magic. And the other thing is you want open brackets. So these are kind of the order that you should kind of be doing things. And the last one, which is perhaps one of the more important ones, wow, my pen is not working very well, is number 4, is the last thing you should do when you're solving questions, typically, not always, typically, is multiply or divide. And if you kind of keep that in mind, it'll help you as you go and solve different kinds of questions. So kind of keep that in mind. Now, this is just suggestions. So I'm going to show you ways that I found students have found success over the years of teaching. But with algebra, the cool thing is, as long as you follow the golden rule, you can kind of do whatever you want. So there might be better ways, more efficient ways to do things. Maybe. I've seen students do things a little more efficiently sometimes than me, but I'm going to show you the things that I've found over the years that have seemed to work really, really well. So there's my caveat, is that once you get pretty decent at algebra, you can start mixing the rules up a little bit and solve as you see fit, as long as, of course, you're showing all your work. Let's get to it, shall we? Here we go. So your first example. Let's start off nice and slow. So 5x minus 2, whoop, that's a 2, is equal to 13. Okay. So again, something to keep in mind is that you have two sides to an equation. There you go. There are your two sides. And you want to make sure you're doing the same thing in both. Now, you got some different things going on here. Your goal, remember your goal is what? Your goal is get x by itself. Get x alone. That's your goal. You want x to be lonely. So what do you need to get rid of? You need to get rid of this 5. And you need to get rid of this negative 2. And that would leave you with x all by itself. So how are you going to go and get rid of those things? That's the question you have to be asking yourself. Well, a few things. You know that between the 5 and the x is multiplying. And you know here with this negative 2, this is like an adding and subtracting thing between those kind of two terms. So remember back to the last thing I said is you usually want to do your multiplying at the very end or dividing. So you should be thinking about what can I add or subtract right now. And let's just go and add 2 to both sides. Because if we do that, that is going to get rid of that negative 2. Remember, we're always adding here. So this is negative 2 plus a positive 2. And that's just going to wipe it out, right? That just wipes it out. And I'm left with 5x is equal to 15. Great. Now how to get rid of that 5? Well, again, your last thing that you can do, we can see that we're almost done here, right? It looks like it's almost done. Is we're going to go and divide this side by 5. And again, do it on both sides. And there we go. 5 divided by 5 just leaves you with the x. So x is going to be just 3. Cool? Okay. Let's move on a little bit. Let's do another one. Let's go pumpkin orange. Let's do another example here. let's do one with some brackets. So I'm going to go negative 2 bracket 3x minus 1, that seems pretty good, is going to be equal to, I don't know, 22? Do I want it to be 22? Do I want it to be? I want it to be negative 22. Sure. Okay. So here we go. Again, you have two sides to the equation. And I'm going to show you a shortcut in a second. But typically, when you have brackets, you want to go and open your brackets. So I'm going to go and do that. I'm going to go and distribute. And I get negative 6x plus 2. Remember, it's plus 2 is equal to negative 22. Now we're kind of back to that first example that I just gave you. So now we're going to go and subtract 2 from both sides. Now this one always causes a little bit of problems because remember we're always adding here. So that's just going to eliminate this. But this is negative 22 plus another negative 2. That's going to give you negative 24. And we still have our negative 6x. Cool. Now let's go and finish it all off. Let's divide both sides by negative 6. Both sides by negative 6. Don't forget, negative divided by another negative is going to give you a positive 4. Now, I do want to show you, for those of you at home that love to see little things like this, I'm going to write the question again over here. Ooh, I jumped over there. And I just want to show you one little kind of shortcut, which I always love showing this to students. Is this brackets kind of protects everything here. And if you take a look at this coefficient in front of the brackets and this number over here, they both have a common factor of, you got it, negative 2. So you could go and divide this entire side, let's get a different color here. You could go and divide this entire side by negative 2, and this side by negative 2. Now why would you want to do that? Well, that would eliminate these, leaving you just with 3x minus 1. And this would become positive 11. So you can go and kind of do that if those numbers work out really well. That stuff in the bracket stays as it is. So you could do that. And if you kind of, stick with me here, if I added 1 to both sides, you would have 3x equals 12. There you go. And divide both sides by 3, and then x equals 4. Same answer. So I just want to show you that little kind of shortcut, which is kind of cool. Now, the other thing that I mentioned in the video in the little notes was about fractions. So let's just take a look at fractions. And I'm going to start here. So I'm hoping 4 to 5x, I'll say minus a half, is equal to, I don't know, 9/10. Now, I do want to show you one thing here. I'm hoping you all have your calculators beside you, right? Don't we all walk around with our calculators? Well, if you have a phone nowadays, you have calculators always, right? So you have calculators. And I'll show you 2 ways to do this question. I'm going to show you 2 ways. Is there a preferred way? I don't know. So I'll show you the B way over here. But I'll show you the A way right here. I guess. This is the exact same questions we've just been doing, but there's fractions. Don't be freaked out. So you could just go and do this. Okay, I'm going to add a half to both sides. I'm going to add a half to both sides. So you can do that. And again, 9/10 plus a half. It's not the easiest question in the world to do. So do make sure you have a calculator and you get 7 over 5. So you'd have 4/5 x, oops, there we go, is equal to 7/5. And then, to get rid of a number with the x there, you just divide it by 4/5. Divide this by 4/5. When you're dividing, you're really multiplying by a reciprocal. But when you have a calculator, you literally hit the divide button. And when you do that, you get 7/4. So now x is equal to 7/4. So if you have a calculator, you can just go and use a calculator and use those numbers, and there you go. Version B, so I'm going to show you version B over here. So let's go and get the question again. So 4/5 x minus a half equals 9/10. Now, if you want to go and get rid of fractions, which is sometimes a really good thing to do, you can just multiply everything by the LCM. So that, LCM of 5 to and 10. So, you know, hopefully you can say like, oh, the LCM of those numbers, this is a pretty easy one, is 10. So how I do it is I write a giant 10 right here. And then you have to listen to this, is I basically say 5 times what is 10? 2. 2 times what is 10? 5. 10 times what is 10? 1. So these numbers up here are going to do all the multiplying by the numerators. So you go 2 times 4, which is 8x. 5 times -1 is -5. And 1 times 9 is just 9. You then have gotten rid of all the denominators, and you have a new equation. This one looks a lot more comfortable for a lot of students, especially if, let's say, for some strange reason, let's say you've forgotten your calculator, and you don't want to start doing a bunch of fraction-y kind of stuff. This is a great way to go about it. So we're back to here now, right? So we're adding 5 to both sides. All right, and students, I can hear you're like, oh wow, that doesn't look too bad. So 8x equals 14, and then x would just equal 14 over 8. And of course, you would simplify that, divide both sides by the top and the bottom by 2, so it's 7 over 4. Same answer, there you go. So that's a way to get rid of fractions, which I find is really, really helpful. Okay, so those are some of the kind of classic ones. Getting rid of fractions and that sort of thing, which is always helpful. The other situation you're going to find for multi-step is when you have variables on both sides. So here we go. So you want to get, and I like just using the letter x, right? I mean, it could be any variable, but get x basically on one side, right? That's what we want to do. Typically, students love to have it on the left side because they get freaked out when it's on the right side. You will get more comfortable as you get more experience in math, leaving the x on the right. But for right now, let's just hypothetically say we always want to have x's on the left. So let's start off nice and easy. 5x minus 3 is equal to, oh, I don't know, 3x equals 7. Okay. Oops. Sorry, 3x plus 7. There we go. You can't have two equal signs. That'd be crazy. So here we go. Again, I want to get the x's on one side, so that means I need to go and, here are my two sides. So I need to figure out, do I want my x's on my left or my right? Most kids want them over here, so that means I need to get rid of this 3x. So some students are thinking like, oh, maybe I divide this by 3x? Maybe I do that? No, because remember, multiplying and dividing should be near the very end. So you actually have to subtract. So you're basically doing your subtracting and adding at the very start. So I'm going to subtract 3x from here. And then do remember I'm adding here. So that's going to leave me with 2x. And I still have that, that -3. And that is going to be equal, that destroys that, is equal to 7. Cool. Now I want to go and add 3. So remember, I haven't multiplied or divided yet because that's near the end. So 2x, that's a really bad x. I've been trying to write my x's a little bit differently now. Like that. I know there's a colleague of mine, this Mr. O'Hara, he always writes his x's that way. So I'm trying to mimic that and try it out and see if I like it. I like my x's like this. It's a little, kind of like a little flare right there. I like that way. That's just me. Back to the math. 2x equals 10. Divide both sides by 2. So remember, dividing, multiplying at the last step. So x is equal to 5. Okay. So there you go. That's not too bad. Shall we do one more? Nah, let's do one more. This is the second time I'm doing this video. I'm really hoping when I finish and I click save on this video, it's going to actually work. Because literally, I did this exact same video about half an hour ago. And I got really, really frustrated. I'm going to change this number on you, sorry. Make it a 4. And yeah, that just happens. That just happens in life. Things crash. It made me quite sad. Anyways, maybe you guys care about that, maybe you guys don't. I don't know. Here we go. So here's a crazy question. I'm going to hypothetically say you don't have a calculator on you. And you're thinking, I don't have a calculator. Gosh, there's a lot of fractions going on here. How do I go about this? Well, again, we're going to go and use the LCM of 3, 4, 12, and 6. So if you're asking, what's the LCM of 3, 4, 12, and 6. That LCM is going to be 12. Okay, so I write a giant 12 here. And then I start to say what numbers multiply to give you that. So 3 times what is 12? Maybe I'll get a different color here. What color should I get? Go green. 3 times what is 12? 4. 4 times what is 12? 3, 1, and 2. And then those numbers multiplied by the numerators of all those things. Be careful, this is a -1 here, so be careful of that. If a kid is going to make a mistake, that's where they're going to make a mistake. 4 times 2 is 8x. 3 times -1 is -3. 1 times 7 is just 7. And 2 times 5 is 10. Now this is pretty manageable the rest of the way. I'm going to go and, oh, this is going to work out pretty cool. I'm going to negative 7x from both sides. And I'm going to show you, how should I show you? Yeah, I'm going to add 3. I'm doing 2 steps at once. Oops. So you're going to see me do 2 steps at once right now. I don't know. Depends on your math teacher. As long as you're showing steps, it's all good. I'm kind of combining that. I'm using colors too, so it should be pretty obvious what I'm doing. And what are we going to end up getting here? Remember, we're always adding. So this becomes just x. This wipes out this. And then this would be equal to, boom, 13. What? Cool. Awesome. Did you enjoy that? Solving multi-step equations? You know what you need now? You need practice. That's right. Because you've just seen pretty much all the things you need to know for algebra solving. But you need to see all the different kind of nuances, situations, and questions. So go find some practice out there. I'm a huge fan of Khan, not Star Trek Khan, Khan Academy. They have great practice in there. Go and Google them. Go there. That's pretty cool. And check it out. Let me know how it goes. If you have any questions, comments, always drop me a note, and I'll get back to you as soon as possible. Thanks for checking in. Have a good day. Well done, Math Padawans. You have learned how to solve multi-step equations. But like all good Jedi, you need to practice. Yes, you learn the ways of the Force and the ways of solving. Until next time, have a great day.